All right. So Lee has been organizing the website, as we just mentioned. Just got the travel grant up there. The rules will basically turn into a Gantt chart. And where can I find that?
Oh, at the bottom.
Very bottom, okay.
The one that, all the way at the very bottom.
All right, nice.
So that was just an Excel file I had made for tracking, or doing a checklist for all the stuff in the rules.
Nice. Oh, that's pretty.
Still needs to be updated for current rules, and then I was thinking about putting phases into it and actually a little more modifications to it. To make it not so congested.
Yeah. I think, yeah. I think this is sufficient. I don't want you to spend a whole heck of a lot of time on it, but let's, we'll just update the names, obviously. I don't think we can really, I wouldn't delete any of these names. No one on the list has told me no yet. So I would just add the current students' names, and maybe we can just use this for a little bit of recruiting too. This looks really good.
I'll go through and double check to see if anything actually changed in the rules. I assume not.
Yeah.
I'll update what we have done versus.
Driver's helmet, driver's visibility. Okay, perfect. Bulkhead. Nice. Roll bar. Okay, super. And then, what do we? Okay, so I guess what I'd like to do. Do you want to just own this thing then, or should anybody be allowed to edit it, or what's the deal? Because I mean.
Yeah, I think. I'm actually seeing if we can edit it on the. We put it as a Google Doc. Well. I wouldn't mind if people wanted to modify it and then just submit it and I'll paste the updated version.
What I'm afraid of though is like two people might go in, it's the same, classic problem though, two people go to edit it.
Well, if they email me both, then I can check, see where they overlap.
Do you have some hard copies? It would be like at the journal.
It would be nice to have a hard copy, I like that.
So just kind of, after I update it, we'll have it.
Yeah, let's go ahead.
It might help if you keep it posted somewhere.
Yeah, I like that. Yeah.
Have you ever heard of RIKE?
What is it?
So W-R-I-K-E.
Yeah, let's check it out.
It's like project management. I mean, it'd kind of be like a Moodle page.
Yeah, I'm glad you mentioned it might be a good.
So I work in the project management office in IT.
Yeah.
Campus, and we use that to manage our
Your to-do list.
Yeah, so it's great because you can assign users, you can give them tasks, completion dates. You can create Gantt charts in it.
Yeah. So I'm guessing we could just more or less copy and paste what we have in Excel into this guy? Is that what you're thinking maybe?
I personally haven't made any Gantt charts. But, I mean, it kind of, I guess, a bit of it probably would be copy and paste, but maybe a little bit of manipulation there.
Let's see. It sounds like, are you kind of married to this URL? I mean, it looks like the software maybe just lives on their site, and you're kind of managing it through their little deal. Okay.
Yeah. So it would all just be a web page.
5 users. That's probably okay. That's probably enough for the team. What do you think?
The way it works is you can, so for the free one, you can get 5 users. So that would pretty much be like your administrator.
Yep.
So then you can have an unlimited number of, they call them collaborators.
Who can view it?
Exactly.
Okay.
You can even give them rights to change things. They just can't manage like, they can't like change hierarchies.
Okay.
They can't assign users to things like that. So,
Okay.
Yeah.
I think well, how, do you have any idea, Brandon, how amenable this would be to printing a hard copy? So
So that's
Just
one of the reasons we started using it was, you can create reports and things like that on like,
nice.
how things look, what you completed, where you're going. And so it's easy to create stuff like that.
Okay.
Doesn't sound bad at all.
Yeah, let's use it, because I think it'll solve that simultaneous user problem and allow, I guess what I'd kind of like to do is maybe see a link to this within our Moodle shell. That shouldn't be a big deal either, right? Pop you out.
One thing that's nice too is, so, like, you can create a task.
Mm-hmm.
On that task, there's kind of a chat room that's specific to that task.
Mhm.
So anybody can go in there and say, like, hey, I'm getting this, or, or if they have, any insights on it.
Okay.
And it's kind of like Facebook too, you can like tag other users, so that,
Oh.
then they're notified that they were mentioned in that comment. So,
Okay.
they can elicit a response.
All right. Can I just maybe task you and Lee with working on that together to kind of get it set up? Does that work? Okay, okay. Groovy. Okay. Now, I think our next, should we work with this a little bit since we're all here now in the room?
Well, I have to update the rules, so it's kind of.
Yeah. Well, I guess what I would like to start doing though is just assigning portions of the car.
Almost do it on the board, then I can transfer it.
Yeah. Okay. Well, let's just do that then. Because I mean, more or less, every single little article has to be matched to somebody. If you screw one thing up, the car will not be able to compete. So it's it's critical that we cover every single component.
One task that's not on there, when I put the frame on top of Jake's truck, I noticed it didn't sit quite flat, so we might have to have it aligned.
Okay.
It might be a little bit out of alignment.
True the frame. I think we might be able to do that ourselves at Sentinel. If not, maybe we'll take it back to the shop, the welding shop. Okay, I'm just going to write a few tasks as well. I'll get this camera going on the whiteboard. I don't know how well this marker's going to show up. Not at all.
Can you reduce the brightness on?
Why don't I think if I could just type into Microsoft Word, can't I?
Yeah.
I mean, we can all see it right up here on the board. All right, here's a few tasks that I'm thinking of right away. So one is design rear suspension. Has that happened to any substantial degree?
Working on
Colton?
it. Yeah.
Okay,
I think
so,
we had plans for it.
so get drawings from Colton. The other one is assess tubing at West Campus. So I know we bought a heck of a lot of tubing, and I want to make sure that it still belongs to us.
So just trying to pick that up and pick up the frame.
Yeah.
Old frame.
Yeah. So maybe Brad and Lee head to West Campus. I'm not going to be here a week from today, but let me look at my calendar. So we do need to hop on that, and I think we just use the same tubing for the rear suspension that we use for the rest of the frame. I guess we could do it Friday morning. What's,
We have class where we can do it, right?
yeah, what times, we have class starting at 8, right?
Yeah.
Those guys probably aren't, and then what's your stop time at, on Friday?
11, it's class is 8 to 11.
You can stop, you're going till 11?
And we don't have a classroom at 10 to 11, so we have to have like an hour of loading anyway.
Okay. Well, then let's just go get the thing, let's go at 10. Okay. Head to West Campus, 10 a.m., Friday the 25th. How should we get there?
The hydrogen powered vehicle.
Should we? We can. We'll take the truck.
If we took the trailer with it, we could pick up the parts and put it in the back of the trailer.
Yeah. We might also be able to get away with just strapping it down. It's not the best, 'cause there's no rack
That thing's
there.
really heavy.
What's that?
That thing is really heavy.
It's not too heavy for the truck. I mean, come on, I know it's heavy, but.
That truck that
Wait,
has the
wait.
plastic thing on the,
All right, maybe, yeah, I don't want to bug Tim for it. We'll get it. We'll get out there and get it. Okay. Assess tubing, and remove old frame. All right, I'll do that. Anybody interested in the rear suspension? I know, and I'm gonna put Corey on it. I'm just gonna say Corey, question mark. I know he's put some time into it as well. And he's still here. Colton's here to some degree. The next one, I wanna make sure we get, what I'm thinking is, let's get the wheels on it as soon as possible. So next one is, design, steering, get drawings from Kevin. Some of these things might even already be in the shell, I just don't know it. So I know Kevin Bissett was working on the steering, and all of these cars have what's called a Ackerman steering geometry, and what that means is that when you take a turn, well, I'll just show you. And the geometry is well known. Probably the images are better. And so this is kind of exaggerated, but showing that the geometry is such that when you make a turn, the inner wheel has a greater angle and therefore a smaller turning radius than the outer wheel. So that's fairly standard. I noticed that we don't have any steering pins on our vehicle, so that's next. Design steering, so head tubes, bearings. Do we have any bearings and that kind of stuff at all?
I haven't ordered any yet.
Okay. At this point, I'm kind of ready to cannibalize both the 2012 and the 2014 vehicles. And so if there are usable bearings in those, let's just go ahead and use them. So look at reusing 2012 and 2014 bearings.
We do a little bit of suspension from the 2014 vehicle.
Some suspension. Oh, we could probably cannibalize some of the 2014 suspension too.
That brake was completely gutted.
Yeah, okay.
pass over back.
Okay, sounds good. Design steering. Those are my first big main concerns, just getting the wheels on the vehicle. The way it rolls, and what we'll also be able to do from that, I'd like to be able to do some experiments where we test and measure the coefficient of rolling resistance.
Do you have any know AutoCAD at all?
He used it about 10 years ago.
Well, it does have all the AutoCAD drawings of the vehicle.
Okay, yeah. Test and measure the rolling is the coefficient of rolling resistance. And as I was mentioning last time, at about 15 or 25 miles per hour, the aerodynamic drag equals the rolling resistance drag. But obviously, the lower you can get the rolling resistance, the better. A lot of things contribute to that. You know, one obviously is the tire pressure. Another one's the tire tread. Another big one is just the wheel alignment. If you've got your wheels towed in, that's another reason for using the Ackerman steering. If you've got the wheels misaligned, rather than actually rolling on the ground, they're actually spinning or sort of screwing themselves into the ground, if you will. So that's why wheel alignment is critical. So test and measure the coefficient of rolling resistance, and from this we should actually get a reasonable estimate of a first guess at our mileage. So obviously, the lower the rolling resistance, the higher the mileage. We'll just peek at that math for a little bit. Should be a little. I think there'll be a little equation here. Sliding friction. Blah 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 blah. Yeah. So N is the normal force. That's more or less the weight of the vehicle divided by or multiplied by whatever fraction each of the wheels have. And the way it's shown here, it's just a linear equation, but you could imagine that if the weight on the wheels is unevenly distributed, that the coefficient of rolling resistance will actually be a, well, I didn't bring my little pad here, but I'll do the best I can in Word. So if we've got F equals CRRN, and follow along a little bit here too, because this will be part of our final report when we add this to our engineering report. So this is going to be a subscript, so I'm just going to do control equals on that guy, and I'm going to make all of the equation a Times New Roman, and I'm going to make sure that this is italics, this is italics, this is italics, because those are all variables. So I'll just write it. So this is our first little draft of writing our engineering report too. Okay, the force due to rolling resistance is quant as. So here's this guy. Now let me show you how to put an equation number into a document too. I'm going to put a tab right here. I'm also going to put a tab at the beginning of the paragraph. And now I'm going to put an open paren and get rid of that italics. And now I'm going to go up to insert. Maybe it's under references. Always moving on me here. Home, insert. Oh, yeah. gonna insert a field, and this field is going to be a sequence, and I'm going to call it equation, EQ for equation. Hit OK, close paren. Now, for some reason, rather than actually putting a tab in front of the F, it actually did an indent. I don't know if you see that indent up there, but I'll stick a center tab in there, and I'm going to stick a right tab in over here, and now I'll try it one more time. Okay, that's what I wanted to do. I'll get rid of that indent. All right, rolling force is quantified as F equals CRR, where F is the horizontal component of force. N is the vertical. So if you've had physics, you'll recognize that CRR is really, it could be replaced with the coefficient of friction. That's really all it is. It's dimensionless. It doesn't have any dimensions because both N and F both have dimensions of force. F, so as normal force, and CRR is the rolling resistance. Okay, so save this. Did you get her done?
Yep.
RGY 292, 2015. I'm sort of making a to-do list and a little lesson in report writing at the same time. I figure what the heck, we'll take care of it. I'll just call it the to-do list and then post it. Okay, so where F is the horizontal component of force, N is the CRR, control I, and this is a subscript. Now, let's just do a little bit of energy analysis on the vehicle. So the power required to overcome rolling resistance is actually I'm going to rewrite this guy a little bit. Since this is the force due to rolling resistance, I'll just put an RR as a subscript on that guy too. Control I, control equals, and then I can change this guy, RR, control I. Now, the beauty of having put that little equation in earlier and sort of taking my time formatting it, I can use that again, like so. Copy, put it here, paste, and now I'll just change that F to a P, I'll change the C to an F, italics, and then times V. V is just the velocity of the car. So power is force times velocity, and hopefully what you can see right away is that it's a linear relationship. So the faster you go, the more power it takes. It's a straight line as a function of velocity. Later we'll get into the aerodynamic drag, and that is a function of velocity squared. And the power is actually a function of velocity cubed. I'll update this field, call that good. Okay, power required to overcome rolling resistance. One way to do this is just to say comma PRR. We'll do our readers a favor and make sure they know what all the variables are. Where control Z, where is actually part of that sentence, so it doesn't get capitalized. Where V is the vehicle velocity. Now, velocity, as you know, is a vector. It's not a scalar. Normally would have a component, and I would call it something like v sub x. But in this case, the car is going forward, and we don't have to worry about it going sideways or up. So there's only one component of velocity that we have to worry about. And maybe more appropriately, we call it the vehicle speed, because technically speed is the scalar value of the magnitude of velocity, but it's fine. Speed. We'll call it speed. In the direction of travel. Okay, now, the experiment for determining the rolling resistance, all we really need to do is push the car at an initial velocity with a known speed and more or less determine how far it goes before it stops rolling. Because as it's moving, its energy is being dissipated. So we did this a few years ago, and it was actually pretty good data. So don't need to get too deeply into that for now. But those are my first kind of get the car up and rolling on wheels. What do you guys think would be a reasonable deadline for that? It's the end of September now.
Is rolling or rolling with the actual transmission?
Just rolling, just kind of off the ground. Give it a shove.
I shouldn't take too long. Just depends on if you want like that. If we're going to do a differential or not, or if we're going to try and do independent one motor on each rear wheel, like Brian was mentioning.
Mm-hmm.
But if you want it just to be able to, something basic that we can modify later, it shouldn't take long.
Yeah, because I'd like to be able to get the thing up and rolling, even if it doesn't have any power. That's fine, because then we can start to work on the brakes, we can work on the steering, work on the seat, and really until it's rolling, it's tough to do a whole heck of a lot of that. I'm thinking November 15th is probably a little aggressive, but by Thanksgiving break kind of it would be a good deadline for that. So let's get design rear suspension. Let's have that finished by October 10th. 2 weeks. Okay, finished by October 10th. And I'll just say review on September 30th. So I'd like to just get that going. Email Colton, whatever you need to do. We'll figure out who's going to take the lead on that. So design review on September 30. Assess tubing, we've got a date on that. Design steering, so finished by October 10th. Rolling by Thanksgiving. Well, so test and measure the CRR. So we'll have a goal of performing this test before Thanksgiving break. Other thing, and this will not be all we do. We're working in parallel on the batteries. Jake's going to do the windshield wiper. Someone's going to hop on the body. But all right. Okay, so let's say before Thanksgiving break. How about that? Design steering finished by October 10th again. Design finished by October 10. So design by October 10th. Built by November 15th. Okay. Well, that's probably enough out of me. Let's just kind of see what we can do here in the room with, kind of the next task that you guys actually want to try to knock out by next week. Sound good? Okay.
Did you guys have any, or did you already mention where you guys have interest on the individual?